Hello everybody! Welcome back to Catalysis, Discovery and Technology Tool, where we discuss and explore catalysis and its future in science and medicine. In this lesson, we will be going on the journey of natural gas to transportation fuels. So, let's get right into it. This lesson will answer the questions: why is converting natural gas to transportation fuels necessary? How can natural gas be converted to transportation fuels? And can other chemicals usually made from natural gas be converted? Why is converting natural gas to transportation fuels necessary? So why do we need to convert natural gas to use it as a transportation fuel? Transportation fuels must be liquids to have sufficient energy density. Gas fuels can be used, but the storage tank must either be impractically large or at dangerously high pressures. Natural gas is primarily methane, CH4. Methane has a critical temperature of negative 82.6 degrees Celsius. This means that methane cannot be liquid above this temperature, regardless of the pressure. In order for methane to be liquid at a safe pressure, it must be stored below negative 160 degrees Celsius. This is impractically low, so physical means of increasing the energy density of methane are not possible. Since physical processes are not sufficient, we must consider chemical routes to altering natural gas. These processes are broadly described as GTL, or gas-to-liquids technologies. Not all of these processes are new. Fischer-Tropsch technologies were developed in the mid-1920s. Fischer-Tropsch technology has been used occasionally in its invention as fuel prices and availability have fluctuated. Notably, Fischer-Tropsch was utilized by Germany during World War II when they did not have access to petroleum. Currently, the primary source of gasoline and other liquid fuels is petroleum. As petroleum becomes less available or as policy prevents its use, GTL may become more broadly used. Methane is the most abundant source of fuel available in the United States today, so it is likely to be used as a feedstock going forward. Now let's take a deeper look at what Fischer-Tropsch actually is. Fischer-Tropsch is a catalyst-based synthesis process of liquid hydrocarbon fuels. The fuel can be created from coal or natural gas. In the main reaction involved in the Fischer-Tropsch process, hydrogen and carbon monoxide from the coal or natural gas react to form various lengths of hydrocarbons and water. The most common catalysts used in industry for this overall reaction include iron and nickel. How can natural gas be converted to transportation fuels? So, we already know that natural gas is primarily methane, CH4. This is the smallest hydrocarbon. Hydrocarbon meaning a molecule that is made up of only hydrogen and carbon. In order to make methane into a liquid, it must be reacted to form larger molecules. The first step in many of these technologies involves the production of synthesis gas, syngas. Syngas is a combination of hydrogen, carbon monoxide, and carbon dioxide. Carbon dioxide is not always present. Syngas can be reacted in many different ways to produce fuels. That's where it got the name synthesis gas. The first reaction is known as the steam reforming. This reaction is endothermic, meaning energy must be added to drive this reaction forward. The equilibrium shifts to the right at high temperatures. This reaction requires a catalyst, which is usually nickel. This reaction is diffusion limited. This is because the process takes place at high temperatures, so the reaction is very fast compared to the diffusion. This reaction will always form carbon monoxide and hydrogen in a 1:3 ratio. Some processes require different ratios of these chemicals. A second reaction, known as water-gas shift reaction, allows for the production of an additional hydrogen. This reaction is exothermic. This means equilibrium shifts to the right at low temperatures. However, the reaction, like all reactions, is slower at low temperatures. This reaction requires a catalyst also. The preferred catalyst depends on the optimal temperature for the specific need of the process. Both high and low temperature processes exist. From here, there are many processes that can be used depending on the desired fuel. One route to gasoline is to first synthesize methanol from syngas, then further react methanol to dimethyl ether over an alumina catalyst. DME is then converted to a complex mixture, which is usable in current gasoline engines or can be blended into petroleum-based gasoline. The secret sauce of the process is the catalyst used. The catalyst is a proprietary zeolite catalyst. This process is called the mobile methanol to gasoline, or MTG process. Now, can other chemicals usually made from natural gas be converted? Transportation fuels are a significant portion of the chemicals produced to form petroleum, but other commodities are also produced. Can plastics be made from natural gas? There are many types of plastics, but here we'll focus on polyethylene, since it is the most used plastic in the world. The feedstock for polyethylene is ethylene, C2H4. If methane can be converted to ethylene, then the traditional routes to polyethylene will still work. Ethylene can be synthesized from methane via oxidative coupling of methane, OCM. This process has inherent limits on selectivity and is not commercially viable. Because of this, another route is needed. So far, we have assumed that natural gas is essentially methane. Methane accounts for the majority, approximately 90% of natural gas. However, ethane, C2H6, makes up a significant portion of gas, approximately 4%. Ethane can be converted to ethylene in a process called cracking. Cracking heats ethane up to such a high temperature that it breaks the molecular bonds that hold ethane together. Even though only a small percent of natural gas is ethane, this still accounts for a large amount of ethane. An ethane cracker that is to open in 2020 in Pennsylvania has an estimated capacity of 1.5 million tons a year. There are several types of crackers. Some use steam and no catalyst, and some use solid acid catalysts. So what did we learn today? Natural gas, an abundant source in the United States and elsewhere, can be converted to other useful chemicals. Transportation fuels. Natural gas can be converted to transportation fuels, gasoline or diesel, by several processes. These processes are called GTL technologies and have been used for nearly 100 years already. Catalysis is essential for all of these processes. Ethylene. Natural gas contains small but significant amounts of ethane. Ethane can then be converted to ethylene in a process known as cracking. Ethylene can then be converted to a number of plastics including polyethylene, the most used plastic on Earth. Well, that's all we have for you guys today. Thank you so much for watching, and as always, have a good one.